Alrighty. So today we're going to be talking about section 3.3, which, as I mentioned last time, is about measures of relative position. And that has a couple things in it, but then we quickly move on to how we're going to summarize some of these things. So the first thing we have in here is how to find the pth percentile of n data points. Right, so here n is the total number of data points you have, and if you want to find the pth percentile first, you find L, which is equal to n times p over 100. Then, if L is a decimal, round up to get which data point in order is the pth percentile. And if L is a whole number, average the Lth data point and the next one. Right. So we'll be doing some problems with that, but the basic idea is we find this number and then we use it to either come up with the data point that is the pth percentile itself, or kind of like we did with the median, because secretly the median is the 50th percentile. We average and then round, or average and then that's our percentile. So of these, we've already talked a little bit. The quartiles are the 25th, the 50th, and the 75th percentiles. And this one is also called the median. Right, so that sort of trick we did, whether it was odd or even, is what we would do to figure out the median. So this is also called Q1, this is called Q2, and this is called Q3. And another way to find them is that, well, Q2 is the median, and Q1 is the median of all data points less than Q2, and Q3 is the median of all data points greater than Q2. The book goes into some more detail about some fiddly bits about those, but just as sort of a quick way to compute it, that's fine to do. One thing that we might notice, I'm gonna hop by real quick, in our calculator, our calculator also gives us the first quartile and the third quartile, and secretly gives us the second quartile because that's what the median is, right? So if you do the whole trick we've been doing with the calculator all along, it also gets you the 3 quartiles. So once we have the quartiles, we can collect something we call the 5-number summary. Right? And that 5-number summary is the minimum, Q1, Q2, Q3, and the maximum. We also have the box plot in this section, which is really just a graphical representation of this 5-number summary, where you put bars over the minimum. I'm not going to do that, it's right above it. You put bars above the minimum and the maximum and the 3 quartiles. Then you connect the quartiles up with a box, the way I've done here, and then you just draw lines out to the max and min. Now that's the way our book has us doing box plots. There's at least one other way that I know of, but for our purposes, we're going to go with what the book says, and we're just going to put our whiskers, which are what these pieces of the box plot are called, at the minimum and maximum. Draw a line from there to the quartiles, Q1 and Q3, make the quartiles into a box, and then put another line over the median there. Right. Now, the other way of doing box plots has to do with outliers. So, to deal with outliers, we need to know the IQR, which is the interquartile range. Right. And that is just Q3 minus Q1. Remember we talked about range last time. That was the maximum minus the minimum. Well, now we want to find a range again, but this time we just want to find the range of the quartiles, not the range of the whole set, which is why we do Q3 minus Q1. And we find outliers by checking if X is less than Q1 minus IQR times 1.5, right? Or if X is greater than Q3 plus IQR times 1.5, right? And if either of those are true, then X is an outlier. Right? Oftentimes in that case, X would be put like out here. But like I said, the book doesn't do that. The book just has the max and min be the whiskers, instead of these guys being the whiskers. But that is still how you find outliers, so we do still need to know how to do it. And the last sort of idea that's introduced in this section is something called the standard score. And really, they probably should have introduced it last time, because we actually did it multiple times when we were dealing with the empirical rule and Chebyshev's rule, right? So the empirical score, or the standard score, is you find Z is the standard score, and you find it by taking some value X, right, and then subtracting it from the mean, and dividing it by the standard deviation, right? So that is all in one formula, exactly what we were doing for the last 2 problems of last section, where we took the value that we were asked a question about, we subtracted it from the mean, and then we divided it by sigma to figure out how many standard deviations away from the mean is X, right? So that's all this question is asking, or that's all this formula is asking. It turns out that's super important for pretty much the whole last half of the semester. You're going to be finding standard scores a lot, and going from Z back to X as well. But really all it is how many standard deviations away from the mean is some value X that we care about for some reason. Right. Okay. Let's see. So the problem with doing problems like this, or doing problems from this section, is that for it really to be interesting, we have to have a lot of numbers here. And if we have a lot of numbers here, then I have to write down a lot of numbers. So let's, I'm going to cheat that a little bit. Let's find the 15th, percentile of the following data set. And by cheat, I mean I'm going to use a stem and leaf plot. One of the nice things about a stem and leaf plot is that they tend to be automatically in order. So right, and our key is that 3 bar 1 equals 31. So, if we want to find the 5th percentile, remember first we need to find L, which was N P over 100. Right? So we know that P equals 15. Right? And N in this case is, well, we've got 4 numbers from this row. We've got 4, 4, 4, 4. So N equals 20. Right? And if I calculate that out, that winds up being 3. Right? So 3 is a whole number. So if we go back up to our rule, we said if L was a whole number, we need to take the nth data point and the next one up and average them. So N being 3, we need to take the 3rd data point. Right, so the first data point is 31, the next is 31, the third is 32. And the next data point up is the 4th data point, and that is 34. And so the 15th percentile is 32 plus 34 over 2, because that's how we average things. 66 over 2, 33. Right? So, something that I'm going to have to bring out a different calculator for. Let's find the Let's find the 66th percentile of the above data set. Right? So in that case, we need to find L again. N is still 20. We're working with the same data set. P now for this problem is 66. And let me figure out what that is. That is 13.2. So in that case, we got L as a decimal point, right? So if we drag our way all the way back up here, if L is a decimal, we want to round up to get which data point is the pth percentile, right? So here, 13.2, so we want the 14th data point, right? So 31 is the first, 31 is the second, 32 is the third, 34 is the fourth, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th. Right, so this guy gives me the 14th, and that's 78. So that is the 66th percentile. Right. Alrighty. So that's how we find percentiles. So now let's find the 5-number summary. Let's see. No, I'm going to be nice and go ahead and write it in order. Okay, yeah. Let's have that be 28. Right. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers here. Right, and so looking for the 5-number summary, remember that's going to be the min, the max, then Q1, Q2, and Q3. Right, min and max are the easiest, especially since I did it in order here. Right, so we've got 1 and 28. So now, I would recommend doing the median process personally, just because the percentile process is a little bit annoying. But recall when we did median 2 sections ago, we said if you have an even number of things, right, this is the halfway point exactly, so we need to take the average of the 2 things around it. So that's 29 over 2, so that's 14.5. Right. Now, one of the nice things about drawing this big thick bar here is that Q1 I'm going to find by looking for the median of this. And Q3 I'm going to find by looking at the median of this. Right? All the numbers to the left of the median and all the numbers to the right of the median. So, finding the median of an odd number of numbers is a little bit easier. Right? Because it's just the one exactly in the middle. Has 2 above it and 2 below it. 2 above it and 2 below it. So Q1 is 12. Q3 is 21. Remember again that this 5-number summary is also something that your calculator can do. I'm not going to go through plugging all 10 of those numbers back in, but the min x, the quartile 1, the median, the quartile 3, whoops, and yep, it lost it. Oh well. And the max x that were there, you can go back in time and look at this on the video. That's the 5-number summary, right? So we can figure it out there. So we found our 5-number summary. So let's draw a box plot for the above data. Right, so in that case, we want to draw a number line first. We want to go at least down here to 1. We want to go up to 28, so I'm going to go ahead and mark it as 30. Actually, let's mark this at 0 for the same reason, right? Because then I can mark this as 15, and I can at least try to be somewhat to scale. I mean, it's not great, but I can try, right? That means that my minimum's going to be here, my maximum's going to be here, Q1 is going to be a little bit above 10, Q3 is going to be a little bit above 20, maybe a little bit less above 20. Q2 is going to be a little bit below 15. Then I want to match all these up with a box. And I want to match the whiskers out with lines. Right, so that's our box plot for the data. Box plots are generally more useful when you can draw something to scale. My stuff isn't greatly to scale, but we can sort of kind of pretend and get the basic idea of it. Right? And lastly, I want to check the above data for outliers. Right, and if we recall from above, our check for outliers needed the IQR. Alright, so that's Q3 minus Q1. So that's going to be 21 minus 12 is 9. It then said that we wanted to multiply that by 1.5. So IQR times 1.5 is going to be equal to, you can throw that into your calculator. Whoops, should get 13.5. And let me check something real quick. Yeah. So then we take Q1 minus 13.5 is 12 minus 13.5, which is negative 1.5. So there's no lower outliers. Right? And Q3 plus 13.5 is 21 plus 13.5, which is 34.5. So there's no upper outliers either, right? None of our data values, let me get those back into view. None of our data values are bigger than 34.5, and none of them are smaller than negative 1.5. So according to this measurement, we don't have any outliers. All right. So next up, our last problem for this section. Find the standard score for a value of 72 given that mu equals 80 and sigma equals 1.2. Right? So we go back to our formula. Standard score says we're looking for what z is when we take x minus mu over sigma. Most of those values that we want are given already, are labeled already, right? So we know that mu is 80, and we know sigma is 1.2. And whatever data point value is given us is always going to be what x is. Right? So up top we get negative 8, and then we're dividing that by 1.2. So when we plug that in, we get negative 6.6 repeating. So our standard score is negative 6.6 repeating. Right? And it's as simple as that, right? Mu is Mu and sigma are almost always going to be labeled, or perhaps in previous parts of the problem you had to find them yourself. And then really it comes down to figuring out what they want you to use for x, right? So that'll always be something from the data set that's given to you, right? It might be it might say something about an individual score, or a particular value, and we plug it into this formula and figure out what our standard score is, right? So that z is always going to be the standard score that we're looking for. All right, so that rounds up our chapter 3 stuff. So after this, we're going to be venturing into chapter 4, where we start to do some basic probability stuff. So we're gonna take a step away from a little bit of this formula and calculating stuff, and instead talk about some probabilities. So I will see y'all then.